Okay, now we'll proceed with chapter 2.6. All right, I'll just give you a brief idea of what we are doing on this chapter, and then we move on. It is implicit differentiation. Another important thing, the way chain rule is important, the same way implicit differentiation is important. Now, first thing, what do we mean by implicit? Now, there are two words, implicit and explicit. All right, I'm just writing something over here, and from there you can easily figure out what is the difference between implicit and explicit. Like if it is y equals 2x squared plus 3x plus 5, just as an example. And second one, I'm just writing y raised to power x equals x raised to power y plus 5xy plus y raised to the power 2x. Now, can you tell me the difference between these two equations? Anyone? Just unmute yourself and see and explain if you see any difference in these two equations.
Well, the second equation has variables and numbers and the exponents, as well as our y isn't just a regular y, it's a y raised to x.
Okay, good. And what about the first one?
It's more straightforward.
Straightforward. In the first equation, x is separate and y is separate. Okay, that is the explicit function. But the second one is, the red one is implicit function. Implicit function means we cannot separate x and y. Now we are dealing with such functions where we cannot separate x and y. Now we are dealing with such functions. All right, let's see. Just look at this one here. It says the function that we have met so far can be described as expressing one variable explicitly in terms of another variable. Like they have given us one example, y equals radical x cubed plus 1, y equals x sine x. Now, these are explicit function. Y is on one side and x is on another side. Some functions, however, are defined implicitly by the relation between x and y, such as x squared plus y squared equals 25. Now this is still easy. Why it is easy? I can write y squared equals 25 minus x squared, and then I can calculate y as radical of 25 minus x squared. All right. But when it comes to functions like this, all right, now we have to figure out how we differentiate these functions. How we differentiate these functions. Okay. Now, they have given us one example. In some cases, it is possible to solve such an equation by y, like the previous question. It was x squared plus y squared equals 25. All right. Now, when I write it as it was x squared plus y squared equals 25, I write y squared as 25 minus x squared, and then I calculate radical or square root. So y is plus or minus radical 25 minus x squared. All right. In some cases, we can do that. In some cases, we can do that. So two of the functions determined from the implicit equation 1 are fx is positive and gx is negative. Now these are the two functions. Positive means the circle is above x-axis, negative means the circle is below x-axis. The graph of f and g are the upper and lower semicircles of x squared plus y squared equals 25. All right, now this is one thing when we can solve. Since it was plus or minus, plus means the upper part, minus means the lower part. And how do we get this equation? We get this figure from this equation. I know this is equation of a circle with the center 0 and radius is 5. This is equation of a circle with the center 0, 0 and circle with the center 0, 0 and radius 5. Okay, now let's look at the next slide. This is the second one. Now, just don't worry about the shape or the equation, all right? Do not worry about the different names that we are about to see. The main thing is we need to understand the concept. Now, over here it says, it is not easy to solve equation 2. It is not easy to solve equation 2. Now, if you read this here, this is equation 2, x cubed plus y cubed equals 6xy. It is not at all easy to get x on one side and y on another side. Okay, now, this is what we have to deal with now. We have to deal with such functions. How do we find derivative of such functions? This shape is called a Descartes, and this is called a folium of Descartes. That's what we are trying to do right now. Okay, now let's look at, well, we'll come to those questions very soon. Let's look at this. The graph of 3 such functions are shown in the figure. Now, it is actually the same thing. If you look at this, let me break it with blue. Let me break it with blue. This part is 1, this part is 2, and this part is 3. All right, these two come in graph 1, this one is in graph 2, and this one is in graph 3. Graph 1, graph 2, and graph 3. Make sense? This is 1, this is 2, and this is 3. Now, if we look at these, well, right now we are not dealing with the graphing, it is just for understanding. When we say that f is a function defined implicitly by equation 2, we mean that the function is x cubed. Now, what was the function? What was the equation actually? X cubed plus y cubed plus 6xy. Now, from this function, I will write, from this equation, I'll write this equation. What is it? X cubed fx cubed minus 6x fx. Wherever I see y, I have replaced that y with what? Fx. I've replaced that y with fx. Now, what is the use of replacing that y with fx? All right, let's check that. Now comes implicit differentiation. This is what we have to do. Let me directly go to a question. Let's check this question. That's an easy question. Fx, it can be solved easily. Let's check. The function is x squared plus y squared equals 25, and I want to calculate derivative. Now, when I calculate derivative, what I'll do is I'll calculate derivative ddx on both sides, differentiate both sides. All right. Now, when I differentiate the first x squared, what is the derivative of x squared?
2x.
2x. All right. We simply get 2x for the first part. Now, please make sure when you read this, let me write it down here. The left side is ddx of x squared plus ddx of y squared. Now, according to chain rule, can you tell me what is derivative of y squared? Anyone, just make a wild guess. Do not say it is 0 because it is not 0. Y is a function of x.
2y.
Okay, you say 2y. That's it? Partially right. We are missing something.
Oh, yeah, dy over.
Make sense?
Mm-hmm.
2y, first initially I differentiated normally. Normally it becomes 2y. Then I have to differentiate y with respect to x. And this will be equals to what? 0.
Who is that snoring?
It is someone.
She ain't got hoes.
Okay, so we got it now. The left hand side is 2x and 2y dy over dx, and that is equals to what? It is equals to 0. And now I simplify. How do I simplify? I'll just take this 2x to the other side. So it will give me what? It will give me 2y dy over dx equals to negative 2x, and then divide by 2y. So we have dy over dx is negative 2x over 2y. They cancel out, and we are left with dy over dx equals x over y. Make sense or not?
Mm,
Can you go over that last part again?
yeah.
Okay, first thing. When we started from here, the first part is we differentiate on both sides, right? Now, if a function is x, and I know what is the derivative of x, or x squared, x cubed, whatever involves x. So this is x squared. Derivative of x squared is what? 2x. Derivative of y squared is what? It will be 2y, and then I have to differentiate y with x. 2y dy over dx. And on the right hand side, it is constant, and the derivative of constant is 0. All right? Just hold on for a second.
Who is that?
No, really.
I really don't know.
That gotta be Emmanuel doing that.
So it was what? It was actually 2y dy over dx equals negative 2x. All right. From this point, what I do is I divide both sides by 2y. 2y and 2y cancel out. Over here, 2 and 2 cancel out. So we have what? Dy over dx as x over y with a negative. That's the answer. Make sense?
Makes sense.
Good. All right. So at point 3, 4, we just plug in 3, 4 and get the answer. And equation of tangent line, we have been solving equation of tangent line. We got the slope. This dy over dx is a slope. So y minus y1 equals mx minus x1. So we get the equation of tangent line.
So dy over dx is equal to m?
Yeah, it is a slope.
Okay. Okay.
Dy over dx is the slope. Slope of a tangent line. So that is actually your m. All right, now the same thing is the next, let me write it down. Okay, now this is another way to solve it, but I will not recommend this way. The way we have solved, that was pretty good. All right, do not solve it this way.
Okay.
All right, this is implicit function. All right, I'll be sending you few questions on implicit function today, but before going to implicit function, I just want you all to finish up chain rule. Okay, from now onwards, like what's the time right now? It's just 10:35. Well, I recommend if you all can sit together using a group me, or if you want Zoom, I can just start another meeting and you all. I hope you all know that you can write on the screen.
What?
Yes, you can write on the screen.
When?
That would have been so much easier this whole time.
Who's doing this now? See,
How do you?
I just had to try it.
if you have that touch screen iPad or your cell phone, if you're working on cell phone, you can write easily.
But how
Oh.
do I do it?
Okay, do you see
Oh.
it there on the left-hand side, bottom?
I got you. I see it. Okay. Oh wow, I didn't. Oh, I'm sorry. I just had to try it out. All right.
Okay.
Well, there you go. So we can So we can point out things if we. All right.
That's right.
See, look at you.
We're gonna be
Okay.
learning technology.
Oh,
Y'all bored.
Learning technology. Yeah.
Wait, so y'all trying to have him start another group or y'all trying to go back to sleep?
Back to